where so I want to be able to view the voltages, let's say the current and the power that this particular resistor is taking. So in Pscad, the way you are going to do that is essentially the way this works is we need to bring in a multimeter. So go in components right here, bring in a multimeter, just drop that, use again a wire mode and reconnect this. Now go into this multimeter and we're gonna say, and it's telling you, hey, what do you want me to measure? I'm gonna say, hey, you know what? I want you to measure, RMS voltage. I want you to measure RMS current. Just pick digital for now, and then reactive power flow, and then the active power flow is what I want you to measure. Now the thing is measuring this stuff here, and you will notice I said instantaneous voltage and currents are null. So come to signal name. And you can see the stuff which is null there, it's just in signal names because I didn't turn it on, so I can't, these are not available. But these options that I did turn on, those are signal names. It's saying, hey, I'm measuring this stuff here. If you want to be able to view that data, you don't give it a name, no problem. But if you give it a name, then you can view that data in a scope. And I'll show you what that means. So how will we name this power source? We're going to name it Q underscore source. We're going to name this a V underscore line to line RMS from the source. And then I'm just going to say I underscore root RMS. And then this is the source. Okay. And press OK. So, and one thing right here, I'm just going to say, animated display plus, yes, it will start to animate some of these properties here as it's going to run this simulation. So, but as I'll show you what I mean, I have now created the signals, but I still haven't set up the way for us to be able to see that data. So now the simulations will be recording the data. There will be recording that into the signal names that we provided, but we just haven't seen those signals just yet, right? So you could see now it's running, it's annotating, it's showing that the voltage at this point with respect to the ground is 30 kV. This is the power and the Q that you're seeing, but what we're not seeing here is, we want to be able to see what the waveforms are like. So for us to be able to do that, you got to come in components. You're going to drop signal. So there's only one, so you could, all the control signals, so like signals of measurements, there's a lot of other stuff like control signal, like PID controller controls, like the items that are not true electrical signal, that are not voltages, that are not electrical properties, I would say. Those items like the electrical power flow, we have a node button here. So that is generally used, let's say, if there's a lot of stuff here, you want to be able to move the circuit, let's say here. So what you could do is you can put this node here, and then you can then re-pick up this node and put it right there. So then essentially this is more of a housekeeping to make the canvas work. Or if you want to go from one module to another module, so these nodes will kind of start to come into play from imports and exports. But I just want you to know that there's electrical nodes that are different, and there's control signals or signal nodes that are different. So for me to be able to view the data and this particular signals, this is that particular node, which is called master data label. And you can see over here, it says master X node. So those are two different things. There's not many, there's only two things. So right now we're gonna just use that. And I wanna be able to pick up this guy right there. Okay, so now I've got a way to view, I've got a way to now, extract the signal name, but I need to be able to view it. And so you need to come back again in components right here and click this component right here. So now it's taking all the data and putting it to the graph, but we still haven't been able to view it. So you're going to right click it, come in graphs, and then say add overlay graph with signal. And now finally you will be able to view that signal. So I'm just going to copy paste this thing a few times here because okay, so I've got a Q there. Then I've got a different, so I'm going to come in signal names, copy this signal. The signal name needs to be exactly the same, okay? And then I'm going to come back here and then copy this and bring this in here as well. So now you'll see when I'm going to click, sorry, so in power, I'm just going to see power and a Q I want to see side by side. So I'm just going to click inside this graph. Now they're side by side. I want to see the voltage, but I don't want to see it side by side. So I'm going to click the top bar, do a control. So first you got to do a control C, then control V. And now let's say the same thing with current. I'm going to control C the current. I'm going to click on this scope, control C, come back to this graph pane. And I don't want to view this alongside. I just want it to have its own graph. So I'm going to click at the top, and I'm going to create another graph. And sometimes you just have to make it bigger for you to be able to see it. Now, the good thing is that all of these particular graphs will just have exact same axes. If I wanted, I could have just right-click this and create a completely separate graph if I wanted to. And now this bottom graph, because I pasted this graph here from current, brought it here. So now this graph and that graph are basically entirely the same. But to avoid confusion, I'm just going to delete that. But I want to let you know you can do it however you like. Now let's just run it and see what we see. Okay, so now again it's compiling. First, no errors, great. And it should start to run. There we go. Okay, so now we're gonna come in here. Right there. Okay, so you're gonna click on each of these graphs, and if you click R, which is basically the option which is zoom, and if you see reset all extent, so it just makes it the graphs makes it easier for you to see or see the information. So you can see right now the simulation is at 230, 250, 260 second, but my graph is only up to 140. So I want to be able to see that data. So you click it, and then you click R, and then it will basically extend the R X. It will basically extend the X limits or Y limits if there's some data which is not visible to you. I like to see my power in, I'm just going to make it purple. And I like to see my Q as blue. So like that. And I like to see my voltages as red, because it's always about voltages when you're performing those transient studies. I did something wrong here, probably. Color. Oh yeah, I clicked on points. I just gotta click it back to lines, bold, press OK. Now this looks good. Okay, and then I like to see my current as generally orange. Okay, so are we now getting the information? So I'm gonna zoom in, click on this middle, click C, and that brings me this cross hair marker, and you can see right here all across is 230. So you can see the right side value, which is your Y value. It's a 230 kV. And then if I'm going to look at the X value, you could see 66.39 if you do that calculation correctly. So yeah, so that's really all. We can now see the current, which is equal to 66.39. We got the resistor, and now we can start to see these values, and that's how you can create a very basic circuit. And just as a recap.